So just take 1 second. I'll be back.
Alrighty, beta. Okay. So, Chavi beta, we'll continue with our discussion on the 2D motion. Now, any particular reason Centum had missed out on 2D motion part yet, or that was just not part of the exam, but they have covered it?
So actually, this test happened 3 weeks back.
3 weeks back. Okay. So it's kind of an old story then.
Yes, sir.
So where are you guys in your classes? You guys are covering force and motion now?
Yes, sir.
Okay. How far ahead have you gone into the force and motion?
So I think we'll be starting with pulleys now. I think in maybe next class or something. Yeah.
I see. Okay. So I think I hope the sessions that we are having, they should be re-emphasizing some of the things, and I don't mind that we are lagging behind the regular coaching classes, because that allows us to cement what we have learned. Okay, so in the beginning part of 11th, that is important. Aage chal ke will be taking the lead, as I mentioned a couple of weeks back, but that will happen sometime around March next year. Okay, so let's move on to the next one. So we finished the swimmer and river. So we solved all the problems, all the previous year's problems, JEE Main, JEE Mass, and NTA. So now let's quickly look at this particular scenario wherein a group of particles, so I'm talking about number 21, so let me get into it. So what we have in this particular scenario is a group of particles which are moving towards each other at all times. At all times, they're moving towards each other. So this seems kind of an interesting scenario. So let's understand this a little bit better. So let me just zoom in a little bit. Okay. So here we have 3 particles which are located on the vertices of an equilateral triangle, and at any time A is moving towards B with velocity v, B is moving towards C with velocity v, and C is moving towards A with velocity v at all times. So let's see how they will be moving, and what we will see is that they are always making a right angle triangle just because of the shear symmetry. We'll try and understand that symmetry part a little bit better as well. But interestingly, the triangle that they're forming keeps getting smaller and smaller and smaller. And what we are interested in is understanding how long will it take for the 3 particles to collide with each other, to meet with each other, or come to the center. Take it up. Yes? Does this make sense? Does the scenario make sense?
Yes, sir.
Okay, Ruchika, are you back?
Yes, sir.
Okay. Now, instead of 3 particles along a triangle, you could have been given, let's say, 4 particles along the 4 vertices of a square. Right? So let's say A, B, C, and D. So at time t equals to 0, A starts moving towards B with speed v. B starts moving towards C with speed v. C starts moving towards D with speed v. D starts moving towards A with speed v. After a little while, let's say B moves a small distance. Now A's velocity will start to change, right? So the velocity vector will start to rotate, right? So it'll come here. And B is tracing C, so B will not just see, C is not stationary. If it was stationary, then B will come along the edge. It will move along the edge BC. But since C is moving, it will also come here. Can you see that all the four particles will be having symmetric displacements, right? So B will be here, C will be here, D will be here. Correct, no? The velocity is pointed this way. Always pointed towards each other. So if you connect, because they have moved by the same distance, right? So, and their motion is symmetric, they will continue to form a square. They will continue to be along the four vertices of a square. Okay, just that the square will start to become smaller and smaller and smaller. Same thing here. Now, in this case, if you see, A is moving towards B, so B is moving towards C, C is moving towards A. So, as you can tell, with a similar logic, B starts to move towards the center, and A is tracing it, C is tracing A. So they end up forming, or the path traced by the three, they are symmetric, right? Yes. Okay, so the question is, how long will it take for them to come to center? Any thoughts, any comments, Vita? Ruchika, Chavi, how long will it take for them to reach the center? Let's talk about the equilateral triangle. Let's call this as A. For the square also, let's say that the side is of length A. So how long in the two scenarios, in case of equilateral triangle and in case of square, how long will it take for the particles to come together to meet at the center? How would you guys approach it?
So we can find out the displacement, final displacement, because we know it's in the center.
Okay. This is the net displacement. Okay.
So इसमें approach separation वाला concept use कर सकते हैं.
Approach separation. Okay. So before I talk about these steps, Ruchika, any thoughts, Beta? How would you approach it?
Sir, I'm still thinking.
You're still thinking. Let me ask you guys a question. O is the center of all the squares or the triangles formed by the three or the four particles at all times, right? In case of equilateral triangle, O is the centroid. O is the centroid, and it remains the centroid of all the equilateral triangle at all times. Are you guys convinced? Because they have to be equidistant from O, right? Yes, just by sheer symmetry, they are all equidistant from O. Yes?
Can we say the component of the velocity of each particle towards O will always remain same?
That is correct. Yes. So if you look at it, let me look at this scenario, square. Now for A, if you see its component along AO, what is it? It is V cos of 45. This component is V cos 45, no? Right? Yes, beta?
Yes, sir.
Yeah, same thing for B. Component of the velocity of B Along OB is V cos 45. Same thing for C, same thing for D. Yes? Shall we be convinced? At time t equals to 0. At time t.
Yes, sir.
Right.
Yeah.
Now, let's look at the shaded one. Right? Now, this is again forming a square. And since O is still the center of the square, this angle is still 45. Similarly, this is the new velocity vector for B. And this angle is still 45. Just the sheer geometry of the square. Right? O is the center. A, B, C, and D are at the 4 vertices of the square they are forming. So obviously OB has to make an angle of 45 degrees with the sides of the square. And note that the particles are always moving, trying to move towards the, or along, at any given instant, they're moving along the sides of the square. Correct? At that instant, the velocity is along the side. The component of the velocity towards the center O is still V cos 45. In fact, that's the case always, even if the square reduces like this. So let's say A is moving towards B, B is moving towards C, C is moving towards D. Look at the velocity vectors. They're still making the component towards O is V cos 45. Is that right? So component of velocity towards O or pointed towards O is V cos 45 at all times. Right? So what does that mean? That every second these particles are inching towards or moving towards O. How much distance are they covering in 1 second? V cos 45. Correct, no? At every instant, at every second, in every 1 second, they are covering a distance V cos 45 towards O. Yes? So initially, they were at a distance of A by root 2. A by root 2, no? This is O. Distance of A from the center. This is A by root 2. Is that right? Check कर लें बेटा. OA is A by root 2.
Yes, sir.
So how much time will they take to reach the center? Time taken will be the distance divided by the velocity.
A by V.
A by. Sorry, what is this capital A? No, sir, this should be small a. Small a.
So is the velocity of all of them different or the same?
Same beta. Same.
Yeah.
Otherwise, they will not be, their positions will not be symmetric. Right?
Yes, so that's what I was thinking. Yes.
Then it becomes a slightly trickier problem. Now, what about the equilateral triangle? Same approach, right? Here the angle would be V cos of 30. The component of velocity vector towards the center is V cos 30. Now, what is the distance OA? What is the distance OA, beta? सेंट्रॉइड का किसी भी वर्टिस से कितना डिस्टेंस रहता है बेटा?
2/3 of height, right?
You're saying, sir, this is actually A by 2. So this must be A by 2 Cos of 30. That's what you're saying? You're saying it should be a by root 3. Is that right?
Yes, sir. Huh.
Okay. Okay. In that case, I agree with you. So a by root 3. So time taken would be a by root 3 cos of v cos of 30. I think I got it right. ठीक है बेटा? So 2a by v. Check कर लें, is this right? मैंने कहीं मैथ में I hope I've not made any mistake in the math. Just check it, beta. Just check it once. We're good? Please confirm.
Yes, sir.
Ruchika beta,
Clear, sir.
clear no? Let's solve some problems. Well, we have already done that. This is the four people K, L, M, and N initially at the four corners of square of side D. Each person now moves with uniform speed V in such a way that K always moves directly towards L, L moves towards M, M towards N, N towards K, and so on and so forth. The four persons will meet at a time. Right? That's what we did, no, just now. How much was it?
Sir, sir, d by dt.
D by. Let's move to the next one. So we'll look at the motion of the connected objects. Motion of the connected objects. We will have a thorough session on this tomorrow. But for today, I just want you guys to get warmed up a little bit, right? So let's look at this scenario. Now, in this scenario, what you have is you have two strings, P and Q, being pulled downwards with a certain speed. Let's call it U. And the other end of the two strings is connected to the mass M. Okay, so the question is when the strings are making angle theta with a vertical, any individual string from pulley A to mass M or B to mass M, when they're making the angle theta, at that time, what is the velocity of mass M? With how much velocity is mass M moving upwards? Do you guys want to go ahead and give it an attempt? Give it a try?
Yes, sir.
Okay.
Sir, can you just describe the question one more time?
Okay, so we have these two pulleys A and B, and these two strings from P all the way connected to mass M. They're passing over the pulley A. Same thing on the right hand side. You have the string connected to mass M on this side and then passing over the pulley P. Now, P and Q, both the ends are being moved with velocity U. So when at the instant when these strings are making an angle theta with the vertical here, what will be the velocity of the mass M? What is the velocity of mass M? P and Q are being moved downwards with constant velocity U. Constant velocity U.
So we have to find the velocity of the mass in terms of, say, the velocity of the rope.
In terms of U and theta. In terms of
U by cos theta.
U by cos theta. So, Beta, shall I try it or attempt this problem from a couple of different ways? Shall we do that?
Sir, yes, sure. Sir, but I'm getting u by 2 cos theta.
U by 2 cos theta. Okay, so let's explore. So I'm going to start with the approaches, then you guys tell me when you have followed one of these three approaches, and then we'll figure out where we went sideways. Approach 1, right? So establish the relationship in the linear variables, right? Linear variables, not the angle theta, but linear variables. So what are the different variables here? Distance y, the distance of mass m from, let's say, it can be either from the roof, from the ceiling, how far is it, right? L is the distance of the string from pulley A to the mass end, and D is the distance of the pulley from the center of the two pulleys, right? Essentially, from the pulley A till the line passing through the mass end. So, what is the geometric relationship there? Well, they're forming a right angle triangle. So we can write L square is equals to D square plus Y square. Now, what is the velocity of M? Velocity of M will be dy by dt, or shall it be minus dy by dt? Minus dy by dt, because it's positive. Y is reducing, so dy is negative. So we want to make sure that we add a minus sign just so that we get a positive number for the velocity of mass m. Anyway, that is not important here. We're only interested in the speed. Okay, so we're interested in, if you talk about speed, we're interested in dy by dt, magnitude of dy by dt. Okay, so let's figure out if we can determine that from this relationship. So let's differentiate that with respect to time t. So whenever we differentiate a variable, a polynomial, let's say x squared with respect to y, with respect to t, but let me just make it more generic. X to the power n, then it is essentially n, power comes forward, times x, and subtract the power by 1, multiplied by dx by dt. Okay? So apply the same logic here. So what do we get? So 2L dl by dt is equals to, now d is not changing. So the rate of change of d would be 0 with respect to time, right? So d is not changing with time. So dl by dt by dt is 0. So this is 0 plus 2y dy by dt. Okay. In other words, L dl by dt is equals to y dy by dt. What is dl by dt? dl by dt, by the way, is also a negative quantity, but dl by dt is at what rate this string or this length between the pulley and the mass m is reducing, at what rate. And well, that will be the rate at which we are pulling it downwards. Right? So if you pull it by 1 meters, the distance between A and M is going to reduce by 1 meters. Right? So dl by dt must be u. Okay? So I'm going to write it here. So L times u is equals to y into dy by dt. We're only concerning ourselves with the magnitudes now. Both are negative. Dl by dt is negative, dy by dt is negative, but we're only concerning ourselves with the magnitude. So dy by dt then is simply u y by l. Okay. What is y by l? Cos theta. U by cos theta. So this is our first approach. Are there any questions on this approach? Any questions on this approach?
No, sir.
No. Let's take the second one. Chavi, beta, you're okay, no?
Yes, sir.
So approach 2. We'll mix the linear variables, the translational variables. Translational means the variables along the standard coordinate axis x, y, z. So we'll mix them with the angles. Okay. So let's call this distance y. This is L. So obviously y is equals to L cos theta. Yes, beta? Y is equals to L cos theta. Now, if you differentiate with respect to time, what do you get? dy by dt is equals to dl by dt cos theta minus, don't forget the differentiation of the other term, L sin theta d theta by dt. The reason we have minus is if you differentiate cos theta with respect, or differentiate cos theta, you'll get minus sin theta. Minus sin theta. Yes, Peter? Clear? Okay.
Yes, sir.
dy by dt is what we're trying to determine. That is the speed v. And I'm going to concern ourselves with the magnitude on. So we need to figure out what is d theta by dt. At what rate is this angle changing? So we need to learn how to establish the relationship between the rate of change of the angle to the other, to the translational variables, right? Let's see how do we do it. Let's say the mass comes here after some time. So the new angle then becomes this, okay? This angle then becomes theta plus d theta, where d theta is the same. Are you guys convinced? Yes? No? Yes, Peter?
Yes, sir.
Okay. This distance is, I said, is dy. Correct, na, Peter?
Yes, sir.
Okay. The rope, assuming that this d theta is very small, so the rope has shortened by this much. This is dl. Correct, Nabita? Yes?
Yes, sir.
Okay. So can I say that dy cos theta is dl? Let me redraw the diagram here. This angle is theta. This was my dl. This is the new L dash, right? So what I'm doing is I kind of, I said this length, let me select this length, which is also L dash. Now this angle is very small, let's say 0.1 radians, right? Or let's say 0.1 degrees, let's make it even very small, right? Then these angles are almost 90 degrees, no? Correct, Nabita?
So I didn't get this part.
Okay, so in an isosceles triangle, if this angle is very small, then these two angles near 90 degrees, no? They approach 90 degrees. Let's say this is 1 degree. 1 degree. How much are these angles? Beta. Beta is equals to 180 minus 1 divided by 2. 179 divided by 2. Right? Very nearly 90 degrees, no?
Yes, sir.
Okay. Okay. Why am I proving that? Because when I said this is my L dash from here till this point, and then I joined this line. So I was just trying to convince you guys that this angle is nearly 90 degrees. Okay, because now it's a right angle triangle. Which angle or which triangle? Let me use a different color. Let me use a black color. This triangle is the right angle triangle. Correct, no? And this angle is theta. This side is dy. So dy cos theta is dl. Dy cos theta is dl. Correct, no? Yes, Peter?
Yes, sir.
Okay. And what is this length? Can I say L d theta? Because L dash is very nearly L, because we are talking about differential changes. So for all practical purposes, even if I would write it as L dash minus dl, that's very small. So I can still call it, instead of writing it as L minus dl times d theta, I can very well write it as L d theta. Why? Because when you open it up, you get L d theta minus dl d theta. dl d theta is obviously very, very small. This is a fair approximation. So this is one relation relating dl with dy in terms of theta, and then the other is L d theta. So what is L d theta? Dy sine theta. So dy sine theta is L d theta. Don't worry that, hey, we could have solved this. The approach one was far easier. So why are we even bothering with this? Well, this will become important because in certain questions, we'll look at the scenarios wherein you will be asked to determine that relationship between the translational velocities and at what rate certain angles are changing. So we need to know how to establish those relationships. It will take some amount of practice, but worth it. We are clear, beta?
Yes, sir.
Yes? Okay, good. So now we have all the relationships that we need. So we can, in fact, for our purposes, we could straight away say dy cos theta is dl, right? Dy cos theta is dl. So if you were to differentiate or divide it by dt on both sides, So we could have very well gotten our answer just by writing this. V is equals to u by cos theta. Okay? V is equals to u by cos theta. This is interesting. Even I'm trying to figure out what was the purpose of, or how do we make use of this? And how do we convince that we have not moved up on this relationship? So let's reconcile that everything is in the world still makes sense. So let's revisit that equation. Okay, so what do we want to do there? On the right hand side, we want to convert everything in terms of dl by dt, right? So how do I connect dl by dt? So let's look at this equation. So what do we have? So I can write this as, if I look at these two equations, 1 and 2, let me divide them up. So what do we get? So we get sine theta by cosine theta is equals to L d theta by dl. I'll take dl to the left hand side. I'll divide it by dt. Okay. So my d theta by dt is 1 by L dl by dt sine theta by cos theta. Okay. So let's put it back into this equation. So what do we get? We get v is equals to dl by dt. Let's keep it like that. So dl by dt is how much? dl by dt is u, right? So we have u cos theta minus L sine theta, or rather I should say L d theta by dt is u sine theta by cosine theta. Okay, sine theta by cosine theta into sine theta. We just need to watch out for the signs here. So d theta by dt, right? See, d theta is a positive quantity and we need to correct that error here. So d theta is increasing, dy is decreasing. So we need to introduce a negative sign when we are writing that expression. Here both were negative, so we shouldn't have cared. Now we need to convert this into minus to plus. I hope it's making sense. If not, do ask me the question. So what this means is then v is equals to u cos theta. I'm going to take u out. So we get u cos theta plus sine square theta by cosine theta. Well, that'll give us u by cos theta. Okay. So we have been able to get to the relationship from that side as well. Now, this was actually a straightaway relationship. If you were to draw this geometry, you will straight away find the relationship between dl by dt and dy by dt. Yes, Peter? So I'm going to call it this as the approach 3. So let me recap the 3 approaches we talked about. So in the first approach, we looked at the translational variables or the linear variables, x, y, and the length. And we related how the rate of change of one is related to the rate of change of the other. So we use that the geometric relationship L square is equals to b square plus y square, and we found the relationship between the velocity of mass m and the velocity of the strings u. In the second method, we used the angle as well as the linear variable. So we said y equals to L cos theta. We then took the derivative and then we replaced d theta by dt by dl by dt. Anyway, so now the third approach is where if you were to geometrically draw out what is the dy, right? Draw the geometry relating dy with dl. So from that geometry, we straight away get the relationship that the dy by dt is u by cos theta, right? That's our approach 3. Fairly efficient approach 3. Yes. Now, in many the same, the YouTube videos and the coaching institutes, you will see that teachers are explaining that to get the relationship between the two, this is how they tend to explain it. That if V is moving, if the mass M is moving with velocity V, right, then how much distance has the V covered, right? So if you look at the components of the V, right, so it will have component like this in this direction, right? So there'll be V cos theta. V cos theta. So in other words, the string is moving in this direction, or you can say that in some ways the mass M, it has a component in that direction, which is V cos theta, and that should be equals to U. Okay, so V is U cos theta. Now this will start to make sense now, but it can be fairly confusing because there are still a lot of doubts left in mind, right? Are we saying that M is moving in that direction with velocity? Of course, right? So anything, let's say you are moving in this direction, right? Then obviously you are moving, you can say that actually if you take two perpendicular directions, then you are covering this distance. Let's say you move by this much, then you have covered this much distance in this direction and this much distance in this direction. I'm not drawing it right. So let's see. Okay. Correct? No? So somebody can make a claim, yes. So if you are here, then actually along this coordinate axis, if you were to draw these axes as your coordinate axis, then you have moved, let's call it this is x, this is y, then yes, you have moved by this much distance along x, this much distance along y. So your projection on those two perpendicular directions has moved by that much. Yes, but don't confuse yourself in this method. And I'll not talk about the confusions or the how students get confused, but they do get confused quite a bit there. Okay. If you get doubts, do ask me. It's very important to clarify such confusions. Anyway, are we clear on the three approaches we took? Approach 1, 2, 3.
So I'm getting confused in the second and the third one.
Second and the third. Okay. So let's take a different example altogether. Let me see if we have a good problem that we can look at. Okay, maybe this will, but let me actually find a better problem. Just give me a quick second. Okay, so can you, oh, not this. Okay, let's have fun with this one. Okay, so what are we asked to derive here? We have been asked to derive. So what is given? First of all, we are given that a rod of certain length, right, is one end is resting against a wall, the vertical wall, and another end is on the horizontal floor. Now this rod starts to fall. So the end along the vertical side, it starts sliding along the vertical wall, and the other end on the horizontal floor, it starts to slide along the horizontal floor. Right? Now the question is, at the given instant, when the rod makes certain angle, what will be the relationship between the velocity of, let's say, can I write it here? Let me see. Nope, I cannot write. Oh, I can write it. What happened to the previous one? Okay. There we go. I think we can write. So what is the relationship between, let's say this velocity at that time is, let's say this is A, this is B, this velocity is VB, okay? And this is sliding downwards. So let's first establish the relationship between VA and VB, and then let's figure out at what rate is this angle, at this angle changing, okay? At what rate is this angle changing? So let's call this angle as theta. So what is d theta by dt? So how would we approach this problem? So let me ask you guys first. We'll do all these problems. By the way, there are 20 different problems we're going to practice. So we should get fairly clear on how to approach such problems tomorrow. Right? But for today, it's just our introduction. So let's establish the relationship between the velocity of point A and the velocity of point B. What would that relationship be? So if I were to call this distance as x, this is y, then x square plus y square is equals to L square at all times. If I were to differentiate with respect to time t, so what would I get? 2x dx by dt, which is VB, plus 2y dy by dt, right? dy by dt.
So minus dy नहीं होगा?
Yes, it will be minus dy by dt. So we will keep it as dy by dt, but when we replace it with the VA, we'll write this as minus VA. We'll say 2x VB minus 2y VA. VA is what? Speed of A, right? And A is kind of moving downwards. Yes, Peter?
Yes.
Okay. So this is 0. So we get the relationship between VB and VA when the rod is having a projection of x along the horizontal, projection of y along the vertical. Now the second question comes, how would we determine the rate at which this angle theta is changing? Ruchika, any guesses on how you would approach it?
So हम sorry.
Yes, Peter? The way you would do it is, or the easiest way I can explain is, keep B fixed at that place, right? Now, rotate it by the same angle d theta, right? Rotate it by angle d theta. You'll get here. Correct, no? This is length L, this is length. Yes? Now, move B by this much distance so that now this point A is back again on the wall. Break the motion into 2 steps. Rotate it, keeping B fixed by d, rotated by d theta, okay? And then just translate it here. Okay, beta? So this is dx, the distance by which B would be moving, the end B would be moving in time dt, which is same as this one. What is this? This is L d theta. How much is this angle? What is this angle? This angle is same as theta. Let me see if I can change colors here. I should be able to change colors. Okay, there we go. So now let's look at this triangle. Yes, Peter? This angle is nearly 90 degrees. So what do we get? By the way, this In fact, we're not interested in this triangle, we're interested in this triangle. This is the distance by which A has moved finally. This is dy, right? So L d theta cos theta is dy, and L d theta sine theta is dx. So if you know either the speed of A or B, you can straight away find d theta by dt. Did it make sense? On the scale of 1 to 5, where are we? 1 means I have not understood anything at all, right? 5 being absolutely I've understood it all. Where are we?
So 4 point.
4 points?
So 4.5.
4.5. Chavi?
So मुझे वो last में जब आपने the smaller triangle part that I'm not getting.
This triangle part, the one that I drew in the end.
Yes, sir.
Yeah. Why don't you do this, Vita? Attempt that problem on your own. Do you know which problem is this? Let me bring it up. So I've shared these extra practice questions, the advanced practice questions for you guys. So go in here. Let's just see where that question was. Keep moving. This was not it. By the way, all these problems that we are switching to, when I click on next, they're all the same type of problems, motion of connected bodies. This is the problem we're looking at, beta. So you can find the angular velocity of the rod using this method. Correct?
Yes, sir.
Okay. So give it a try on your own, and then we'll discuss it again, right? Because in one go, it's very hard to get it. But when you hear it maybe 1 or 2 times, it starts to make sense. Okay, so we'll keep moving. So let's solve a few problems. Let's see what do we have in JEE Advanced. Just to get ourselves warmed up, let's solve this one first. I do see chat on YouTube. Now I may have missed these comments, but I'll still address these comments, and they might be helpful for others who are listening in. So what does it say? It's a drop year में मेहनत करने के बाद भी सिर्फ 90 percentile. अब समझ में नहीं आ रहा है लाइफ में क्या करें. Okay. In all honesty, beta, if you have taken a drop and you are at 90 percentile, then I think you should feel proud that you have 90 percentile and that you gave it your best, right? You gave it your best, and then see what options do you have at that percentile. Okay. I will not advise dropping one more year. That may not be the best approach, but again, I'll leave that decision to you. And Ankit, I think you said hello. You may not still be there, but I hope your preparation is coming along well. And then we have another hi. But in any case, if there are any questions, please do put them on the chat. I'll try to address them to the best I can whenever I get a break, when the students in the live class, they're actually solving problems. Okay? So don't feel ignored. I'm not trying to ignore anyone on the YouTube, but it might take me some time to address those points. So I'm going to go back to the live class now. Yes, beta. Ruchika, Chavi, how are we doing, beta?
Sir, is the answer 0.6?
0.6, okay. The wall is at 3 meters, Chavi. Ruchika, beta, is that, shall I go ahead and write down the steps or discuss the steps, or shall I wait? Okay, so let me write this down. Let's say this distance is x, and let's say it is changing. The angular velocity is 0.1. Let's say let's say this is in this direction. Theta is increasing. Okay, so let's first write down the relationship between x and theta. So we can use tangent theta is x by 3, or x is equals to 3 tan theta. Now, if you differentiate with respect to time, you get dx by dt, rate at which x is changing with time, is equals to 3. And beta, what is the derivative of tan theta, Ruchika? What is the derivative of tan? Sec square theta. D theta by dt. We have been given d theta by dt, that is 0.1 radians per second. At the instant when this angle is 45 degrees, what is secant square theta? Or secant square, what is secant 45?
Root 2.
Root 2. Okay, so we get 3 into 2 into 0. That is 0.6 meters per second. So that is the speed which the spot is moving along the wall. And Ruchika, beta, if I were to ask you, or Chavi, beta, if I were to ask you guys, what is the acceleration? What is the acceleration of the spot P? What would you write, beta? At that instant, when theta is 45, we have figured out the velocity, but what is its acceleration? What will that be? What is the acceleration of spot P? Yes, beta? Chavi, beta, you might be on mute in case you are.
Sir, we could double differentiate it, but sir, wouldn't we? So for that, we should know the alpha of or the angular acceleration of the spotlight.
It is given that it is moving at a constant angular velocity. So what will then that will be 0.
So it will be 0. Yes, sir. Then we can just simply differentiate it.
Okay. So then that will be your 3 secant square theta tan theta d theta by dt squared. That's what the acceleration would be. Chavi, beta, is that right? So if I were to double differentiate with respect to time t, so then we'll get 3 into 2 Derivative of secant theta is secant theta.
Yeah.
Shavi, is that right, beta? Secant theta, if you differentiate secant theta, you get secant theta times tan theta into d theta by dt. That means you get d theta by dt squared because there was a d theta by dt already there. The second term, which is differentiating d theta by dt with time, will be 0 because angular acceleration, the rate at which theta is changing, the rate is constant. D theta by dt is constant. So which means d2 theta by dt will be 0. So this is what you will get. So 6 times, then we can figure out the rest. 2 into 10, 45 is 1 into d theta by dt, which we know 0.1 squared. Okay, 0.12 meter per second square. Any questions, any doubt there?
No, sir.
Chavi beta,
Yes, sir.
perfectly clear?
Yes, sir.
Scale of 1 to 5, where are we?
Like 4.
4. So let's solve one more problem. And don't feel exhausted. It's all about exercising mind every day. Exercising every day. The whole idea is to move the average for our brain, right? In terms of tackling the uh, level of difficulty. So we are training our minds to approach the problems from different angles till we figure out what is the right way. So let's look at this problem. And when we are discussing, by the way, just as a quick reminder, when we discuss similar scenarios where we look at rods instead of strings, just remind me to address strings as well, because we will use certain methods which may not be applicable here.
Sir, is it B option?
B for Bombay.
Yes, sir.
Okay. So if I may ask, Ruchika beta, how did you approach it? Chavi, shall I wait, beta? Shall I wait for another minute?
No, that's okay, sir. I'll be doing.
Okay. Yes, Ruchika beta, how did you approach?
Sir, the length of the string should remain constant. So the velocity of the string on the left hand side should be equal to the velocity of the string which is on the right, part of the string which is on the right. So sir, we can find out the components of velocity along the strings and then sir equate them.
So you said this is V, then V cos 45 is the rate at which this is moving upwards, right? And the rate at which this is moving downwards is 2 cos 30 degrees. And this one was V V cos 40. Yes, beta. From here, what did you do?
So I took out the components of the 1 meter as well. So that one meter cos 30 in the direction of the string and one cos 45 in the direction of the other string. So I subtracted the two and then I equated it.
Okay. So you said the 2 cos 30 this angle. Is that what you did? 2 cos square 30? No.
No, sir. I did 2 cos 30 minus 1 cos 30. So that component of the 1 meter per second of this part of the string that's moving upwards.
Okay, good. So 1 cos 30.
So
Cos 30 or 2 cos 30 minus
1 cos 30 is equals to V cos 45 minus 1 cos 45. So because 1 meter per second will also have a component in the direction of the V cos 45. Yes, so then I found out V. So is this the correct approach?
We'll talk about it in just a moment, beta. Chavi beta, do share your approach as well.
Sir, मेरा शायद गलत है. It's becoming all mixed up.
Okay. Just give me a second. So for the students on the YouTube, we're gonna stop the broadcast there. It's getting a little bit longer than intended. In the class, we'll carry on. We'll discuss this problem, but stay tuned for. We'll have regular classes from Monday to Thursday. The whole intent of these classes is to help build your ability to solve problems, and that ability, that analytical ability that you will build, will serve you very well for your JEE Advanced exam and of course for JEE Mains. So I'll see you guys tomorrow, and now I'm going to go ahead and continue with the online class.